Hello, welcome all. Myself Kiran. I am from Department of ISV SPC. Today we will learn about probability distribution. First, let us see the outline. Introduction. What is probability distribution? Types of probability distribution. DPD, CPD, use cases, and the last part is a conclusion. And let us see the introduction. Probability distribution simplified. Brief explanation. Think of the probability distribution as the rules that describe how a random event occurs. Okay, these are some of the rules that tells how a random events can occur. Okay, and importance in simple words. Okay, in statistics and data analysis, these rules are like treasure maps, and they help us to find the patterns, make smart decisions, and understand the world better. That is, with the help of this, we are able to find some of the hidden patterns and make some of the smart decisions, and that is, we can make the sense out of the data. That's what it says. And let us see what is meant by probability distribution. That is, demystifying probability distribution, making sense of the randomness. And and let us see the definition in simple words. A probability distribution is like crystal for randomness. It tells us it tells us how likely a different things are to happen in situation when we can't be certain. That is, suppose when we are in a situation where we are not certain, in that situation we can make use of this. That's what it says. And explanation in simple words. Imagine flipping a coin. A probability distribution tells us the change of getting heads or tails. It tells it's like having a cheat sheet for guessing what might happen when things are uncertain. And let us say types of probability distribution. Two kinds of probability magic. One is discrete and other one is continuous. In discrete probability distribution, it's like a rolling a dice or flipping coins. You count specific outcomes like number of heads in coin flips. Example is dice rolls, coin flips, counting successes in a set of trials. And let us see continuous probability distribution. Think of smooth or uncountable events like measuring and height or time. In continuous probability distribution, we can say we will be getting a range of values, but in discrete probability distribution, we are getting one distinct value. Okay, and it's for when things can happen, uh, can take value within a range. Example is measuring heights, test scores, time intervals. I told you right. In continuous probability distribution, we are getting the range. So is the example says the same thing. If it is measuring heights, we get a range. We are not able to get a distinct value. And let us understand the discrete probability distribution in briefly with the help of this slide. Discrete probability distribution is like a counting variable, counting marbles. It is used when outcomes are discrete, like counting dots on a die. Example, fair six-sided die. Imagine rolling a regular six-sided die. Each face 1, 2, 3, 4, 5, 6, as you know, has equal chances of showing up. Uh, and we saw the probability for this example. I will give as 1 by 6. Suppose when we throw a die, probability of getting 1 is 1 by 6. 1 can occur 1, and total number of outcomes, or total number of outcomes we can get as 6, so 1 by 6. Okay, and picture a bar graph with bars of same height. Each bar represents a number of die, that is 1 to 6, and they are all the same height to show the equal chances. And let us see continuous probability distribution, that is smooth word of continuous probabilities. And continuous probability distribution is like measuring the things that can take any value, not just a whole number. That is, we can say it as range. Okay, and it is used for situations where we have infinite numbers of possibilities. Example is normal distribution. Think of the measuring people's heights. Heights can be anywhere along a range. As I told you in the earlier slides, right? Continuous probability distribution, we can say it has a range. Okay, that is written here. Okay, and not just a specific values like dice rolls. And imagine a curve that looks like a gentle hill. The hill's highest point in the middle and gradually slopes down the both sides. And let us see the applications. Think of them as crystal balls for making decisions. In the finance field, probability distribution helps the investors to decide where to put their money. Okay, and in the quality control, identify defects to improve products. And in the field of biology, predicts the diseases and outbreaks for better prevention. And understanding these magic rules lets us to make smart choices and build accurate models in various real life situations. Okay, and we have come to the last part. It is a conclusion. Probability distributions are like our guide in uncertain situations. That is, it tells us some of the rules that helps us to come out of the uncertain situations. Okay, and they are of two types, for counting and measuring things. And these magic rules helps us in finance field, quality control field, and in the biology field, in the field of biology. And in the world of statistics and data analysis, they are our secret weapons, and they helps us to make sense of the data, predict the future, and make some of the smart decisions. That is, with the help of these rules, we are able to find some of the hidden patterns inside the data. We are able to make sense out of the data. That is, we are able to make some of the conclusions out of the data, and we are able to make some of the smart decisions. That's what it says. Thank you. I hope you entered the session. If you have any doubts, feel free to write the comments in the comment section, and I am there to assist you. I hope you entered the session. Thank you.